So, for all those people that decided to show up on time, thank you. So, class.
Yes.
Thank you very much. So, we are hopefully finishing this up today. So, it'll make life really easy to actually do the math. So, limits at infinity. We left off at this the other day, I think Thursday. And then Friday we just worked on assignment, right? Worked on homework stuff?
Yeah.
Okay. Finding limits at infinity. Now, infinity is what? It's an idea. It's an idea. So, no, this is the only time I'm going to say this. Okay? I'm just going to start writing up for this. If I see phones out at all, yeah, I'm just going to start documenting it instead. I'm not even going to fight it. I get tired of actually doing it where, how many weeks into it? I try to be nice and slow roll, but no. Huh? Yes, it is. So, infinity is an idea, not a number. Now, the whole idea is taking limits at infinity is referring to racing to infinity. We're taking a race. We're going all the way. You need this plate? Paper towels? Back to the shop. Okay. So as we're racing infinity, something's going to go infinity faster. Now this first one right here is going to go to negative infinity. So that's going to the left, right? So whenever we have a fraction, you guys ready? So whenever we have a fraction, we have the numerator and denominator racing to infinity. So as we plug this in, this is racing to infinity to the left. So if I got 4 over, it's going to the left, so that's like negative 1. Okay, I would get negative 4, right? But what if I change that from that to negative 2? What do I get? What's 4 divided by negative 2? Is it? It's going to be. But I'm just right now. Just give me a second. So you'll see in a second. So as I keep going, this would be negative 2. As the number keeps getting bigger and bigger and bigger on the bottom, it keeps getting infinitely smaller and smaller and smaller. So it started at 4, and it started going down as the bottom number keeps getting bigger.
That doesn't apply to the numerator.
It's not applying to the numerator. Why does it not apply to the numerator?
Because the smaller you go in the numerator, the bigger it gets.
There's no x in this one.
Well, yeah.
Yeah, so in that case, there's no x in this one, and same thing. So we're racing to infinity. So as I get closer and closer, this would give me 1/2, right? That would give me 1/4. So as I keep getting smaller and smaller and smaller, what is my number approaching?
0.
It's approaching 0. As I divide it up by more and more pieces, it's getting closer and closer to 0. So now on this problem here, I'm taking infinity and doing what to it? Squaring it, right? So it says 4 over negative infinity squared. So infinity squared should give me a positive, right?
Yeah.
But that's going to be really, really big. Really, really big, right? A really, really big number. So what's that going to make that eventually go to? 0. Whenever the denominator is going to infinity, it's almost like this is a perfect thing to write down. whenever your denominator is going to infinity, it should race to 0. What? Speak, dude. What? Why are you going in there? You can't see? Okay, go ahead. All right, what about the second one? The square root of infinity. It's still going to be infinity, right? Because as the number keeps getting bigger and bigger and bigger, it's still going to go to infinity. The numerator is not changing, only denominator is going to change. Yes, it's going to change at a slower rate, but it's still going to infinity. So that means that this is going to go to 0. Now for this next one here. 2. You okay? Yeah. Sure? Kind of struggling there.
I just miss Vincent.
Huh?
I miss Vincent.
Okay. Anyway. Alright, right here, this is going to be 2 plus 3 over infinity. So that 3 over infinity is going to give me what? 0. So this is going to be eventually becoming 2 plus 0, which is going to give me 2.
I tried doing that about homework, but I don't know. To me, it looked weird. It felt weird. I makes it more sense.
Oh, okay. So yeah. Now these ones right here, numerator and denominator are both racing to infinity. Do you guys want? I'll show you how to cheat on this.
Just cancel every one with an X.
So this is going to be 3 times basically infinity squared over infinity squared. Because this is going to be infinity squared minus 2 times infinity plus 8. So in the greater sense of everything, infinity squared, when I get large enough numbers, infinity squared is going to be so much bigger than just 2 times infinity, right? And infinity plus 8, does that 8 really matter? No, that 8's not going to matter. So this is what my race looks like. 3 times infinity squared divided by infinity squared. This only works when my exponent, my power, my degree of the numerator and denominator are the same. Now, on part B, are they the same? No. Which one is racing to infinity faster? Denominator is racing to infinity faster, right? And what did I say? Even though this is plugging in negative infinity, right? So what's the denominator going to race to as it gets bigger and bigger and bigger? This should go to? Denominator is bigger, so it goes to 0. The negative's really not going to matter because it's going to race to, it could be negative infinity, but no matter what, it's still dividing by that. Whatever that is on top, divided by negative infinity, which is still going to be 0. It'd be a negative 0. Would you be happy with that one? No, but don't put the negative. I'm just joking. Yeah, negative 0.
Oh, sorry, I was just looking back at the top one just in case.
Okay. So, in the sense of infinity, what's gonna matter? Denominator. Anything else? Just the first terms, right? Look, just the plus 10 is not gonna matter. As I'm racing to infinity, plus 10 doesn't matter. So this is actually going to be so as I'm racing to infinity, the minus 5 doesn't matter or the plus 10 doesn't matter. But what is this going to give me? The square root of 4x is, I'm sorry, the square root of 4x squared is 2x, right? Because square root of 4 is 2. Square root of x squared is x over x. My answer is 2. Is that crazy? So neat trick though, right? I can, because in the great sense of infinity, infinity doesn't plus 1 doesn't mean anything. Okay, it's really nothing there. Because as numbers get inconceivably large, doesn't really matter. All right, you guys try these 3.
They have different powers, you can't cancel them out, right?
Yeah. All right, this first one, A, what is that one going to give me? 3. Second one, 0. Third one, that's one we haven't done yet. Which one races faster? The numerator. So the numerator is going to keep getting bigger and bigger and bigger, isn't it? So where do you think that's racing to? Positive infinity. It's going up, right? It's a positive number. So that's going to race up to positive infinity there.
Can you show how to do the first one? I might have messed that up. That's what it simplifies to?
Only care about the highest degree.
Okay, so we get rid of the 2x too.
Yeah, because that.
It doesn't.
Yeah, it's not going to matter because x squared is going to race faster.
Okay.
And that's where we get that. And that's normally where we figure out what type of asymptote we have too. You guys remember? I don't know if at what point you guys did it. I know you guys did it at one point. It should have been algebra 3-4. If you have the same degree, the asymptote is going to be here. Yes? No? Maybe? Kinda? Yeah, it's a horizontal asymptote. Okay. All right. Infinite limits at infinity. Other ones. So as e to the x goes to negative infinity, like I said, just have to have an image of what these graphs look like. You know that this is going to go down to 0 to the left. As it goes to right, it goes to positive infinity. ln. Now, Does this keep going on to the left though? Is there a restriction on my domain here? Yeah. What can it not go to? Cannot go to 0, right? But as it approaches 0, what does it go to? So it would be the limit as x approaches 0 from the right would give me, goes down to negative infinity. And as it goes to the right, this is slowly creeping up here. There's no reason why, even though it is tiny increments going up, it's still going up. It's still increasing. So even at infinity, it's still going to go eventually end up at positive infinity. All right, application. Decomposition of salt in waters. So salt dissolves in water into sodium ions and chloride ions according to the law of inhibited. Say it.
Uninhibited.
Uninhibited. Thank you. Decay. What does uninhibited mean though?
Inhibited is when you're stopping something or kind of like forcing it to stop. So uninhibited is it's like a double negative.
So it's
allowing something to go. So it's uninhibited decay. It's allowing the decay to happen naturally.
forever. And nothing is stopping it. So it's kind of like, all right, when a zombie outbreak, there is a inhibited value to a zombie outbreak. So as the population declines, what is it inhibited by? Amount of healthy people left, right? So eventually you reach 0.
It gets slower and harder to like transfer once it reaches that level.
Yep. Okay. Where A of T is the amount of kilograms of undissolved salt present at the time of T hours. A sub naught is the original amount of undissolved salt, and K is a negative number that represents the rate of dissolution. That's important. It's going to dissolve, right? So I should have a negative number there. If initially there are 25 kilograms of undissolved salt, and after 10 hours there's 15 kilograms undissolved salt remaining, how much undissolved salt is left after 1 day? So initially, time 0, 25, and time 10, 15. And this is in hours, right? Yes, time in hours. Okay. So A of T is equal to A sub naught EKT. Now, we have 2 known values. So this is going to help us out. We have to find what the rate is in between these 2 points. So it's basically we're finding the slope of a line in between these 2 points. But my slope is not just like a regular y equals mx plus b. It is a crazy equation. So at time, okay, at 0, what do I get? I get 25. So I get 25. So that is going to be, let's see. And then I also have the next one, which is going to be, I have 15, and my initial amount was 25. E, K, and my T here is 10. Now, in that second one right there, I only have one variable left, right? What's my one variable? Just K, right? So I could use this known value to solve for K, and that's going to give me my rate. So I could use that to find other values. Do a little bit of math. So divide by 25. So E 10K equals 3 over 5. I reduced it to make my life a whole lot easier. And I'm going to ln both sides. By lnning, what is it going to happen? What's going to happen to my E? It's going to cancel my E, right? So if I ln both sides, I'm going to have ln of 3 over 5 is equal to 10K. Divide both sides by 10. ln 3 minus ln 5 all over 10. Do you guys recall this one right here? When I have a fraction inside an ln, I can separate it by a subtraction sign. That might be a little bit easier when entering this into the calculator to get my rate. So let's go to the calculator then. I know everyone's got the calculator out, right? So let's see who does not have their calculator.
Are we graphing it or solving?
Just solving. So start with my fraction, which was ln 3 close minus ln 5 close. All this is over 10. Now, this is where a lot of people actually struggle with the calculator because they completely forget. So if my calculator settings are that it's going to go to a fraction first, and after that fraction, I have to hit Control, Enter, and it's going to give me that decimal. And in AP, how many decimal points do I try to use? 3. So it's going to be a negative 0.051.
So would that be the limit as C approaches infinity?
No, this is my rate.
Oh, for K.
Yeah, this is only the value of K. So I haven't actually been able to do anything yet, except for right here, finding my K value. So let's see. How long will it take until 12 kilograms of undissolved salt remains? Okay. So I went 12. So I want my output to be 12, right? So in my formula, which is A of T I want my a of t to be 12. Equals a sub naught. What is the a sub naught?
25
What?
is starting amount.
25. That's my initial amount. A sub naught is my initial amount always. So when you see it like that, that's the initial amount, which is 25. And e to the negative 0.051. And my t is my unknown value this time. Because it's asking for how long or how much time. What is my time here? So every time you do one of these, you should only have one variable left when we're solving. All right, do a little math. I get, divide both sides, right? So e to the negative 0.051 t, ln both sides, ln of 12 minus ln of 25 equals negative 0.051 t. And then I just divide by that value. Ln of 12 minus ln of 25 over negative 0.051. Control enter. So what does that give me at time? Yeah, 14.392 hours. Okay, there we go. Find the limit as this goes to infinity. As the function goes to infinity, let's see. So as t goes to infinity, let's go here. Sorry, that's what I want. So that is going to be 25 e to the negative 0.051 times infinity. Now, without putting it in the calculator, we can look at this and say, that exponent, what does it mean if I have a negative exponent? It's what? Kind of. How do I make that positive? How can I make it into a positive exponent? It what? can I move it to the denominator? You guys remember that trick? So that would be a positive e to the 0.051 times infinity.
So where did it put zero? It wouldn't be negative.
Oh, you're right. Thank you. I did a zoom fit just so I could actually see this. So what is happening as I keep going that way? So denominator is going to keep getting bigger and bigger and bigger, isn't it? Probably does. As you could see, the denominator, since it's multiplying, yes, it is going to be tiny, 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 but it's still growing exponentially. It's still a positive exponential growth in the denominator. So that means the denominator is going to keep getting bigger and bigger and bigger. So if the denominator keeps getting bigger faster than the numerator, then it should eventually end up at 0. Does that make sense? Yes? Maybe? Kind of. Did you zone out there for a second, Joseph? You did? Okay.
Yeah, that's like.
That's the reason why I wrote it like this. I rewrote it so we could see that the denominator, as I keep putting that in, it's still exponential, isn't it? It's a tiny little bitty exponential, but that means that that piece right there is going to keep getting bigger and bigger eventually. So it's eventually going to go down to 0.
Can you repeat what you said of like if the
N-
denominator is moving faster than the numerator,
It's always going to be 0. Always 0. Okay.
So if the denominator is moving towards, you're saying a bigger number. What does a bigger number mean? Like literally a bigger number? Because
Like
it's 0.
infinity. No, you're thinking about the y
whichever
value.
one is-
X values.
Yeah.
X values.
Oh.
My x values, as my x value gets bigger, that moves to the right, doesn't it? So therefore, it's my y values keep getting smaller and smaller and smaller as my x values keep getting bigger. So, but there is a limit here that it can only go to 0. That's my population limit again with the zombie outbreak.
Okay, I get it.
So, yeah. I usually throw in zombies and then everyone's all, yeah, I got that. Okay. So everyone's seen a whole bunch of horrible, bad zombie movies.
What was that new one that just came out?
I don't know.
28 years later?
Yeah. Does anyone still care though? 28 years later?
No.
No.
They should have all died. They should have
Yeah.
all decomposed.
Alright. Did we find the answer? Did we interpret it? Now that we got a graph, we can understand that it's eventually going to go to 0 because I don't have any more salt left, right? Eventually, all salt in the water will What's that called? It was dissolved, yes. Alright. Is everyone good? Any questions over those?
So it's like the same earlier where like multiply by a thing, it gets closer to zero. Or no, it gets larger, so then it's something divided by a, so you get closer to zero.
Yeah. If it's divided by infinity, that means that if that one goes faster, that means it's going to go down to 0. But if the numerator is infinity, then it goes up to infinity. But what if it is a negative? Then it goes down to negative infinity. Okay.
The exponent was being multiplied by infinity.
So it's like a negative 3.
It was getting bigger, right?
Yeah, it's a negative 3 in that one. So is that what you're referring to? Give me an example to understand what you're saying. Just make it something on the spot.
I'll talk to you later about that.
Alright. Other people might have the same question.
I can't think about it right now. I can think of a moment.
Okay. Alright. Okay. Alright. So next one, horizontal line asymptotes. So the line y equals L is a horizontal asymptote of a graph of the function for function f for x unbounded with a negative direction, like this. So from here, as x approaches negative infinity, I get a limit for there. And right here, m is going to be a horizontal asymptote of a graph of the function f for x unbounded in the positive direction right here. So what this really means is this is your maximum and that's your minimum for this. So as it's going here, so they're going in different directions. So as it's going this way, I'm going to have my lower would be my m, my upper would be my L. But that's like, calculus 4 type stuff, where you get a capital L is the limit for that one, and capital M would be the lower, whatever that is. But yeah, anyway. Horizontal asymptotes of a graph. You guys already figured this one out. Same degree. Look at the first, and that one's going to give me what? So 3x, is that plus 2 or minus 2? Minus 2. 3x minus 2 and 4x minus 1. Doc, B, graph, control, divide, 3x minus 2 and 4x what? Minus 1. So yeah, that graph that was on the notes didn't go with it. So where do you think that one's happening at? Nope, it's not 1. Where's the horizontal asymptote? Circle these two right here.
3/4.
So at 3/4. Same thing about finding the limit. We know that there it's going to be at 3/4. So going to the right, it's 3/4. Going to the left, it's 3/4. But from right here, it's coming down. Where over here?
So for to find an asymptote, we're just inserting the infinity into it. The asymptote is almost like the limit.
The horizontal asymptote, yeah.
Yeah.
Let's see where we're going. Yeah.
For the other one, is the m always the lower number?
It should be the lower. So when you have two different ones that are doing the limits, so I avoid epsilon delta because they're garbage and I hate doing them for all things. I hate it. I do. So yeah, you'll do an epsilon delta proof where you're gonna have a capital L and a capital M where it's going in between these 2 points.
That was like theory or something?
You? Eventually. I'm not gonna do it though. I'll make you do it. Look it up on YouTube. Anyway. So what?
No, I get it.
Okay. Finding asymptotes of the graph of the rational function. Find all the asymptotes. How do I find vertical asymptotes?
Equal to the denominator.
Very good. Denominator equals 0. And use that trick for the horizontal asymptotes. Where are you trying to roll there? Have a good nap. Okay, we're working on this problem with the notes. Before I take things out.
Whoa. Today, Daddy's birthday.
All right, let's start with the numerator.
Watch out, it will pause in 1 minute.
1 minute? No, I thought we were at 10.
Oh, 9, 10. Sorry.
Yeah. And that's going to give me 3 quantity x plus 2, x minus 2. So let's see, 2x squared minus 4x minus 5x plus 10, 2x x minus 2, negative 5 x minus 2. So we get, the denominator should be x minus 2, x, not x, 2x minus 5. So you had to go through and factor it in the first place. So first, my horizontal asymptote. Where's my horizontal asymptote? Are they the same degree? So it's what? Not 3. 3 over 2. Yep, it's 3 over 2. So I only look at these right here, and the x squareds will cancel eventually.
Also, I found the top one that we look at.
No, you gotta look at both.
Both?
Yeah, you got. It was kind of a cheat since last time it was only 1. That's why it was just the numerator. So when we did the other problem,
The denominator was 1.
yeah, see if I could find it again. Yeah, right here.
Oh, I see.
Yeah, it's implied that it's 1.
Okay.
So that's the reason why it looks like that. So horizontal asymptote was 3 over 2. All right, do I have a vertical asymptote? Blade, do I have a vertical asymptote?
Yeah.
Yes. Do I have 2 of them?
No.
No, why?
Because they cancel out.
it cancels out. And so if it cancels, it gives me a whole where? Very good. And so the denominator, set that one equals 0, and that's going to give me 5 halves. Vertical asymptote is 5/2. Are we good there? Hopefully. Questions, concerns, complaints, conspiracy theories. I don't think that's conspiracy theory.
I didn't say it was. You have a Band-Aid. That's a
Okay.
question.
All right. Anyway, make sure everyone likes, share, and subscribe. That's it for the notes, right? So that means that this homework is going to be, since we went all the way to the end of this class, it's not due tomorrow. It's due the day after. So this is going to be on Wednesday. So tomorrow you could ask questions, hopefully. I'll give you that day to do that. Okay, and then we'll start the new one. Actually, no, we don't have another new one. I'll give you something to review on Wednesday, and then I think Thursday test. Thursday test is good because everyone decides to be absent on Friday, which totally screws up everything. So anyway, oh no, because Friday's a half day. Is it an I day or half day?